Hello everyone and welcome to the Matlax Mathematics Made Simpler, and in this video we'll be looking at geometric progression or exponential sequence. Let's begin. Now, a sequence is called a geometric progression if there is a common ratio between consecutive terms. Now, let's consider the sequence 2, 6, 18, and 54. We can observe that as we move from 2 to 6, from 6 to 18, and from 18 to 54, if we take the ratio of consecutive terms, then we will see that the common ratio is 3. As we move from 2 to 6, we multiply 2 by 3 to obtain 6, and we multiply 6 by 3 to obtain the next term, and it goes on like that. So a sequence as such as this is termed as an exponential sequence or a geometric progression. Now let's see, the first term is denoted by the letter A as in the linear sequence, and the common ratio this time is denoted by the letter R. Now, considering this same sequence here, the nth term of the sequence is denoted by un, so meaning the first term, that is u1, will be 2, u2 will be 6, u3 will be 18, and so on. Now, the general form of an exponential sequence with first term a and common ratio r is given by this, that's ar being a being the first term, a multiplying r being the second term, ar squared being the third term, ar cubed, ar raised to the power 4 being the fourth and fifth terms respectively. Now, the nth term of the sequence, we want to know an expression that we can use to represent the nth term of a sequence, and that is given by un to be equal to ar, an exponent of n minus 1, where n is the nth term. So let's see how we can apply this to solve question. Now we have to find the 8th term of the sequence 50, 20, 8, and it goes on. Now we know that our first term a is 50. We have to find our common ratio, a ratio of consecutive terms. So we divide 20 by 50 to obtain 2 on 5, and that will be our common ratio. We state our formula, and when we put in our values into the formula, then we obtain our answer to be 256 on 3125, and that's the 8th term of this sequence. Let's move on. The second and fourth terms of an exponential sequence with positive terms are 4 and 1 respectively. We have to find the common ratio and the first term. Now we can express the second term as 4 to be equal to ar, where a and r are the first term and the common ratio respectively, and the fourth term can also be represented as 1 to be equal to ar cubed with usual meanings. Now we have to solve these two equations simultaneously to obtain the values of both a and r. We obtain a value of r to be half and that of a to be 8. Simple as ABC. Let's look at the sum of a geometric progression. The sum denoted by s base n of the first n terms of the exponential sequence is given by Sn to be equal to a, that's the first term, multiplying a bracket of 1 minus r raised to the power n bracket closed, all on 1 minus r, where the letters have their usual meanings and r is not equal to 1. Now, in a situation where r is greater than 1, we can substitute their value, their various positions in the formula. Then here becomes rn minus 1 and the denominator becomes r minus 1. Let's see how we can apply this in solving a question. Now we have to find the sum of the first 6 terms of 64, 16, 4, and so on. So we know our first term a to be 64, our common ratio to be 1 on 4, then we substitute our values into the formula, then we get our answer to be 1365 on 16, which means that the sum of the first 6 terms of this sequence is 1365 all on 16. The sum to infinity of a geometric progression. Now the sum to infinity of a geometric sequence a plus ar squared then goes on and on and on is given by s, which is equal to the first term a all on 1 minus r, the common ratio, where r is between -1 and 1. So let's see a worked example. We have to find the sum to infinity of the sequence 2 plus half plus 1 on 8, then it goes on and on. We know our first term a to be 2 and our common ratio to be 1 on 4. We substitute the values into the general formula, then we obtain our answer to be 8/3. Now let's look at other aspects that are related to this geometric progression. We'll be looking at the aspects of compound interest and depreciation. Now, a man deposited 650 euros in a bank at 10% compound interest per annum. Now, we have to find the total amount at the end of the third year. Now, after the first year, or at the end of the first year, we can see that in order to obtain the total amount, we have to multiply 110% by 650 euros, and we will get our answer to be 1.10 times 650. That's the value or the total amount after the first year. Now, because it's a compound interest, the amount obtained at the end of the first year is used as the principal for the next year. So if we continue compounding, we can see that the amount at the end of every year follows a pattern. That is, we have a fixed amount here, and that fixed amount will represent a, that is the first term in a geometric progression. Then we can see that there is an increase. There's an increase. So here we have 1.10, 1.10 squared, 1.10 cube. So you can see that the values here are increasing, and that will represent the r exponent n minus 1 part of the formula for the n term of a geometric progression. So you can see that the amount accrued every year follows an exponential sequence, with first term a to be equal to 650 euros and common ratio r to be equal to 1.10. Now then you can state the formula for compound interest as a to be equal to p into bracket 1 plus r, or exponent n. Now where a is the total amount at the end of n years and p is the principal, while r as usual is the rate. Now the same preamble or the same idea is used for depreciation, which has a formula to be equal to d to be equal to v multiplying a bracket of 1 minus r bracket close exponent n, where d is the depreciated value after n years and v is the initial value and r as usual is the rate. Let's see how you can reapply this to solve question. A man deposited 80,000 euros in a bank at 12% compound interest per annum. We have to find his total amount at the end of the third year. So we state what you are given in the question. We substitute values into the formula, then we get our answer to be 112,394.24 euros, as simple as ABC. Let's look at a question on depreciation. The value of a printing machine depreciated 25% of its value at the beginning of that year. We have to find the value if the new machine is 64000 at the end of the third year. Now let's see. We substitute values into the equation, then we get our answer to be 27,000 euros, meaning that a new machine costs 64,000, but at the end of the third year it will cost 27,000 euros. And I guess you want to try your hands on more questions, and that's all for geometric progression. See you in the next one, but don't forget that this is the